Dear students, let us discuss what is Gauss mean value theorem. If fz is an analytic function in a domain D, and if the circular region mod of z minus z naught less than or equal to rho is contained in D, then f of z naught is equal to 1 upon 2 pi 0 to 2 pi f of z naught plus rho e to the power I theta d theta. So function is analytic in the domain D, and if this circular region is contained in D, then f of z naught is given by this formula. Okay, now since mod of z minus z naught is equal to rho, so therefore z minus z naught is equal to rho into e to the power I theta. Theta lies between 0 and 2 pi. So dz is I times rho e to the power I theta into d theta. So put these values in the Cauchy integral formula. F of z naught is equal to 1 upon 2 pi I integral over c f z dz upon z minus z naught. So therefore f of z naught is 1 upon 2 pi I. Limits for theta are from 0 to 2 pi. In place of z, we write z naught plus rho e to the power I theta. Z minus z naught is rho into e to the power I theta. Dz is I rho e to the power I theta d theta. So I gets cancelled, rho e to the power I theta gets cancelled. So we have f of z naught is equal to 1 upon 2 pi 0 to 2 pi f of z naught plus rho e to the power I theta d theta. Now let's take extension of Cauchy's integral formula for multiply connected domains. If fz is analytic in the region bounded by two closed curves C1 and C2, and A is a point in the region between C1 and C2, then f of A is 1 upon 2 pi I integral over C2 fz dz upon z minus A minus 1 upon 2 pi I integral over C1 fz dz upon z minus A. So what does it mean? See, there is a contour C2, there is a contour C1. Function fz is analytic in the region between C1 and C2. Now A is any point lying between C1 and C2, then value of the function at the point A is given by this formula: 1 upon 2 pi I integral over C fz dz upon z minus A minus 1 upon 2 pi I integral over C1 fz upon z minus A dz. Contour C2 is the outer curve. Now proof. What we do is we draw a circle gamma with the center at the point A. We take a circle gamma whose center is at the point A, and such that gamma lies in the ring shaped region, means it lies between C1 and C2. Now because function fz is analytic throughout the region between C1 and C2, so therefore function fz upon z minus A, now this function is not analytic at the point A. So therefore this function fz upon z minus A is analytic in the region bounded by the curves C1, C2 and gamma, because z minus A is not equal to 0 for any value of z in this annulus. Now because fz upon z minus A is analytic in this region bounded by C1, C2 and gamma, therefore by Cauchy's theorem for multiply connected regions, we have integral over C2, means outer curve, integral over C2 fz upon z minus A dz is equal to sum of these integrals over these two contours, integral over C1 fz upon z minus A dz plus integral over gamma fz upon z minus A dz. Now because function fz is analytic inside and on gamma, so therefore value of fa by Cauchy's integral formula is given by f of A is equal to 1 upon 2 pi I integral over gamma fz upon z minus A dz. Cross multiply by 2 pi I, we have integral over gamma fz upon z minus A dz is equal to 2 pi I into fa. So put this value in equation number 1. So therefore equation 1 implies that integral over C2 fz upon z minus a dz is equal to integral over C1 fz upon z minus a dz plus, in place of this we write 2 pi I into fa. Now take this integral on this side and then divide by 2 pi I. We have f of a is equal to 1 upon 2 pi I integral over C2 fz upon z minus a dz minus 1 upon 2 pi I integral over C1 fz upon z minus a dz. So this is extension of Cauchy's integral formula for multiply connected domains. Okay. Now let's discuss Cauchy's integral formula for the derivative of an analytic function. If a function fz is analytic within and on a closed contour C and a is any point lying in it, then f dash a is given by 1 upon 2 pi I integral over C fz upon z minus a whole square dz. This is the formula for the first derivative of function fz at the point A. So proof is by using method of first principles, which you must have studied in class 11th. What was the formula there? This was the formula. F dash a is equal to limit h tending to 0 f of a plus h minus f of a upon h. This formula had been used in class 11. Okay, so we shall make use of this formula here also. So let a plus h be a point in the neighborhood of a point A. Then by Cauchy's integral formula, we have f of a is equal to 1 upon 2 pi I integral over C fz upon z minus a dz. Make use of the same formula at the point A plus h. So we have f of a plus h is equal to 1 upon 2 pi I integral over C fz upon z minus a plus h dz. So subtract this equation from this equation and then divide by h. So we have f at a plus h minus f at a divided by h is equal to 1 upon 2 pi I can be taken outside, it's common, integral over C fz is also common, and divided by h. Now inside the square bracket we have 1 upon z minus a minus h minus 1 upon z minus a dz, which can be written as 1 upon 2 pi I integral over C fz upon, take z minus a common from here, so we have z minus a into h outside, and inside the bracket we have 1 minus h upon z minus a, and when it is taken to the numerator it becomes 1 minus h upon z minus a raised to the power minus 1 minus 1 dz. Now expand it using binomial theorem for any index, which is 1 minus x to the power minus 1 is 1 plus x square plus x cube and so on when mod of x is less than 1. Okay. So we expand it. We have 1 upon 2 pi I integral over C fz upon z minus a into h 1 plus h upon z minus a plus h upon z minus a whole square and so on minus 1 dz. 1 minus 1 gets cancelled. And now you multiply by 1 upon h. So we have 1 upon 2 pi I integral over C fz upon z minus a. Now here in h will get cancelled and we are left with 1 upon z minus a plus h upon z minus a whole square and so on dz. Now when we take the limit h tending to 0, so then this term will become 0, next term and all the terms will become 0. So we have limit h tending to 0 f at a plus h minus fa upon h is equal to 1 upon 2 pi I integral over C fz upon z minus a multiplied by 1 upon z minus a and then all the other terms 0 dz. So therefore f dash a is equal to 1 upon 2 pi I integral over C fz dz upon z minus a whole square. Okay, now let's find out the general formula for higher order derivatives. If a function fz is analytic within and on a closed contour C and A is any point within C, then derivatives of all orders are analytic and are given by f n a, means nth derivative of fz at the point A is equal to factorial n upon 2 pi I integral over c fz upon z minus a to the power n plus 1 dz. So this is the formula for nth derivative of function at a given point. Now to prove this formula, we shall make use of principle of mathematical induction. What is that method? We prove the given result for n is equal to 1, and then we assume that the result is true for n is equal to k, and using this we prove the result for n is equal to k plus 1. Okay. Now for n is equal to 1, we have f dash a is equal to 1 upon 2 pi I integral over c fz upon z minus a whole square dz. Now this holds good because we have proved it just now. So therefore required result is true for n is equal to 1. Here it should be 1. Okay, instead of m it should be 1. Okay, now let us suppose that the required result is true for n is equal to m. So therefore we have fma is equal to factorial m upon 2 pi I integral over c fz upon z minus a to the power m plus 1 dz. Now we have to prove that the result is true for n is equal to m plus 1. So for that, suppose that a plus h be a point in the neighborhood of a. Then we consider this fma plus h minus fma divided by h. And as in the previous theorem, we proceed and put the values. Factorial m upon 2 pi h integral over c fz. Inside the square bracket we have 1 upon z minus a minus h to the power m plus 1 minus 1 upon z minus a to the power m plus 1 dz. Now take z minus a to the power m plus 1 common from the denominator. We have factorial m upon 2 pi I h integral over c fz upon z minus a to the power m plus 1 into 1 minus h upon z minus a whole raised to the power of m plus 1. Here it should be 1 minus h upon z minus raised to the minus of m plus 1. Okay, because when we take the numerator we have minus sign here. It should be minus of m plus 1 minus 1 dz. So expand by binomial theorem. We have factorial m upon 2 pi h integral over c fz upon z minus a to the power m plus 1 1 plus m plus 1 into h upon z minus a plus m plus 1 m plus 2 upon factorial 2 h upon z minus a whole square and so on minus 1 dz. Plus 1 minus 1 gets cancelled. So we have factorial m upon 2 pi I integral c fz upon z minus a to the power m plus 1 multiplied by 1 upon h. So in the first term h gets cancelled. So we are left with m plus 1 upon z minus a plus m plus 1 m plus 2 upon factorial 2 here h upon z minus a whole square and so on dz. Now when we take the limit h tending to 0, this terms becomes 0 and all other remaining terms become 0. So we have factorial m upon 2 pi I integral over c fz upon z minus a to the power m plus 1 multiplied by m plus 1 upon z minus a. Now this is m plus 1th derivative of fz at the point a, and this is equal to m plus 1 into m factorial upon 2 pi I integral over c fz upon z minus a to the power m plus 2 dz. M plus 1 into factorial m is factorial m plus 1. So therefore f means m plus 1th derivative of fz at a is given by factorial m upon 2 pi I integral over c fz upon z minus a to the power m plus 2 dz. So therefore required result is true for n is equal to m plus 1 if it is true for n is equal to m. So therefore by principle of mathematical induction this result is true for any positive integral value of n. Now here you can see that f dash a first derivative, second derivative all exist. So therefore because fz is analytic, so therefore these functions f1a, f2a, these are also analytic within C. That's what we had to prove. Okay, thank you so much.